In this video, you're going to learn what it takes to solve an equation. Our main focus will be on solving quadratic equations in subsequent videos, but it is important to understand what it means to actually solve an equation. So that's what we're going to do. To start with, consider this linear equation. It says x plus 1 is equal to 3. It's an equation. As you can see, it has an equal sign. There's a left-hand side term and there's a right-hand side term. So this linear equation tells us that x plus 1 is equal to 3. Now this equation involves an unknown variable. And in order to solve this equation, valid values or a valid value for the unknown variable needs to be determined. A valid value for this unknown variable, in this case x, is a value that is such that the numerical value of the left-hand side will be equal to the numerical value on the right-hand side. On the table you see here, 3 possible x values have been listed. So a possible x value is 0, 1, 2. X is a variable, so it can take several values. But I've just placed 3 values here, and we're going to test them to see which of them. We're going to test to see if any of them satisfy this equation. We want to see if any of these numbers here are actually solutions to the given linear equation. So the first solution here, the first potential solution, is the case where x is equal to 0. And in order to test the validity of this solution, we need to replace x with 0 in the given equation and then compare the left-hand side and the right-hand side. If the left-hand side value is equal to the right-hand side value, then we know that x equals 0 is a solution. If it's not, then we know it's not a solution. So when x is 0, the left-hand side becomes 0 plus 1, which is 1. The right-hand side, as you can see, is just 3. So clearly, 1 is not equal to 3. So x equals 0 is not a solution. Let's try x equals 1. When x is equal to 1, the left-hand side becomes, the left-hand side has a value of 1 plus 1, which is 2. The right-hand side has a value of 3. Again, they're not equal, so x equals 1 is not a solution to this linear equation. Let's test the case where x is equal to 2. When x is 2, the left-hand side is 2 plus 1, which is 3. The right-hand side is just 3. As you can see, the left-hand side and right-hand side term are equal when x is 2. Therefore, x equals 2 is a solution to this equation. If you understood what I just explained, then you understand what it means for an equation to be solved. It just means that you need to determine values for the unknown variable, and in some cases variables, but in this case we just have one variable. So the value for the unknown variable that causes the left-hand side of the equation to be equal to the right-hand side of the equation. So this is not a solution, this is not a solution, this is a solution. So the solution to this equation is x is equal to 2. And I've just solved this by using a trial and error procedure. If you were to actually solve this equation, well, all you just simply do is make x the subject of the formula, but that's not the main focus here. The main focus here is just understanding what it means for an equation to be solved. As you know, a quadratic equation is an equation of the form y is equal to ax squared plus bx plus c, where a, b, and c are constant, so they could be real number values, and x and y are variables. And another thing is that a must not be equal to 0. If a is 0, then there's no x squared term. The equation will no longer be quadratic. So here you see a quadratic equation. It's the equation x squared plus 5x plus 6 is equal to 0, which can be rewritten as 0 is equal to x squared plus 5x plus 6. So all I've done is, if I call this equation 1, I've just swapped the left-hand side and right-hand side of equation 1. So this is 6. So this equation here, which I'll call equation 2, is the equation we're going to be focusing on. And this equation, if you just compare this equation to the general form, you can tell that y is 0, the coefficient of x squared, which is a, in this case is 1, the coefficient of x, in this case is 5, and then the constant term c is 6. The solution to equation 2, this quadratic equation, is simply any value that x can take that will cause the left-hand side of the equation to be equal to the right-hand side of the equation. Since our left-hand side is simply 0 here, a solution to this quadratic equation is simply any value of x that causes this right-hand side term to be equal to 0. So what I'll do is, for all these possible x values, I'm going to set the left-hand side term to 0 because that's what the left-hand side of the equation is, 0. So what we're going to do is test all these x values to see if any of them cause the right-hand side to also be equal to 0, thereby causing the equation to be satisfied. So the first case is when x is 1. When x is 1, the left-hand side of the equation is 0. But the right-hand side of the equation is 1 squared. So I'll do that here. 1 squared plus 5 times 1 plus 6. And that is equal to 1 plus 5 plus 6, which is equal to 12. So I'll write that down here. The next case is when x is 2. When x is 2, the right-hand side of the equation is 2 squared plus 5 times 2 plus 6, which is equal to 4 plus 5 times 2, which is 10, plus 6. 4 plus 10 is 14. 14 plus 6 is 20. So when x is 2, the right-hand side of equation 2, the quadratic equation, is 20. Or when x is minus 2. When x is minus 2, the right-hand side is simply minus 2 squared. So remember, I'm just replacing x with minus 2 in this equation. So instead of x, we have minus 2. So instead of x squared, we have minus 2 squared plus 5 times minus 2 plus 6. Minus 2 squared is minus 2 times minus 2, which is plus 4. So I'll just write 4. And then we have 5 times minus 2, which is 10. So plus minus 10 is minus 10 plus 6. So we have 4 minus 10, which is minus 6, plus 6, which is equal to 0. So when x is minus 2, the right-hand side of the equation is 0. When x is minus 3, the right-hand side of the equation is minus 3 squared plus 5 times minus 3 plus 6. And that's simply 9. So this is 9. Let's write it out. Minus 3 squared minus 3 squared, which is 9, plus 5 times minus 3, so plus minus 15 is minus 15, plus 6. So 9 minus 15 is minus 6, minus 6 plus 6 is 0. So I'm just going to rewrite minus 2 squared as minus 2 squared, so it's very obvious that minus 2 is being squared. So now from the table of values we have here, you can see that the only values of x from these 4 values here, the only values of x that cause the left-hand side of the equation to be equal to the right-hand side of the equation are these two here. So when x is minus 2, left-hand side is equal to the right-hand side. When x is minus 3, the left-hand side is equal to the minus side and the right-hand side. But when x is 1 and then x is 2, there's no match. There's no match. So therefore, at least we know that the solutions to these quadratic, valid solutions to equation 2, the quadratic equation, are x is equal to minus 2 and x is equal to minus 3. Quadratic equations always have 2 solutions. The solutions can either be distinct, so totally different numbers, or repeated, so the same numbers. In this case, we have distinct solutions. One is when x is minus 2, the other is when x is minus 3. So from this video, at this point, you should be able to tell that the solution to an equation involving an unknown variable, e.g. x in this case, is simply a value or values of the unknown variable that cause the left-hand side of the equation to be equal to the right-hand side of the equation, i.e. values or a value of the unknown variable that causes the equation to be satisfied.